The diagram shows a triangle LMN. I would instantly be starting to think, is it right angled? Is this Pythagoras? Is it trigonometry, or is it something else? Well, it's not a right angled triangle, so I can't use Pythag, I can't use trig, and you are so lucky because on your formula sheet it says A over sine A, might be the other way up, but doesn't matter, equals B over sine B. Funnily enough, that's called the sine rule. And there is also a formula on your formula sheet for you to write down: a squared equals b squared plus c squared minus 2bc cos a. Funnily enough, that's called the cosine rule. I wonder why they call that the sine rule and that the cosine rule. Possibly something to do with the fact this has got sine in it, that's got cosine in it. And there is a third rule on the formula sheet, and that says we've got the area of a non-right angled triangle is a half AB sine C. Now, by far the easiest of these rules to use is the sine rule. The sides are always opposite the angle, so the sine rule is always about opposites. You would use the cosine rule when you've got 3 little letters and 1 big letter, 3 sides and 1 angle, and if the question mentions area, I'd probably be using the area rule, half AB sine C. This one says calculate the length of L to N, so this side here. What I'd be tempted to do is I'd think, can I use the sine rule? Have I got some opposites? Yes, I do have some opposites. I've got 136 opposite the 15.7 and 12.8 is opposite that one there, so I'd always think I'll use the sine rule to start off with. I'll also completely ignore the questions or the letters that they've got. L, M and N, no use to me. 15.7 is opposite the angle, the sine of capital A, 136, so I'm just going to tap into the calculator. 15.7 over the sine of 136 must be equal to B over sine B. Now the B is this 12.8 over the sine of a letter that I don't actually know, and to be honest, because I know how to use the calculator really well, I'm going to call it B. And you can tap that into the Casio ClassWiz calculator. 15.7 over sine 136, don't forget to close the brackets, right arrow, alpha calc 12.8 over sine B, close the brackets, shift calc equals, and it tells me B is 34.495 degrees, and I'll put that in the diagram. So this angle here, 34.495. Now that enables me to use a little bit of grade 1 maths. Angles in triangles add up to 180, so I know 136 plus 34.495 plus this angle here, let's call it x, must equal 180 degrees. So I'll tap into the calculator. 136 plus 34.495 plus x, alpha calc 180, shift calc equals, and it tells me x, the angle at M, is 9.505 degrees. Notice how I'm using quite a lot of decimal places. 9.505 degrees. Now the question says work out the length of L to N. I'm interested in 1, 2, 3 sides, and I've got loads of angles, and the formula that uses 3 sides and an angle is the cosine rule. And the most important letter in the cosine rule is A, because that's the only capital. We'll call this A. And again, rather like the sine rule, it's all to do with opposites. If that's my angle A there, then this must be side A. And it doesn't matter which way around I put B and C. And I'll just purely put the numbers into the calculator. A squared, I'm reading from this formula here, A squared equals B, which is 15.7 squared, plus 12.8 squared minus 2 times B, which is 15.7, times C, which is 12.8, times, you don't need the times, but I like to put it there, cos of A, which was the 9.505. And you have the calculator, so tap into it. Alpha minus, or x if you prefer, squared. So A squared alpha calc 15.7 squared plus 12.8 squared minus 2 times 15.7 times 12.8 times cos of 9.505. Don't forget to close the brackets. Shift calc equals. Don't be surprised that the calculator takes a little while to get to 3.732007 ... We've got full marks. It does say 3 sig figs. Let's give them 3 significant figures just to show off. 1, 2, 3. Truncated, it's 3.73. That's a 2. It's not big and brave enough to push the 3 up, so 3.73.